क्रिस्टल क्या है? It is a naturally available material. Previously in the watches it was used. Quartz crystal was used previously. Nowadays your smart watch, digital watch, this is not used, but analog watches it was using quartz crystal. Why quartz crystal? Because it is having highest degree of holding the frequency. So there is a rotation of minute hand, second hand, hour hand. So constantly it can be maintaining the frequency. That's why quartz crystal was used. Let me tell you, quartz crystal exhibit a very important property. I think in physics you might have studied piezoelectric effect. Have you studied? Piezoelectric effect. Have you studied or not studied in plus 2 physics? अनुष्को अभिषेक
studied but sir forgotten.
हाँ ठीक है, मैं बोल देता हूँ फिर से. So what is piezoelectric effect? एक एग्जांपल ले लो. तुम एक मेटल शीट को स्ट्राइक करो, ठीक है, और छूने के बाद क्या पता चलता है? उसमें वाइब्रेशन होता है.
Yes sir.
So when mechanical pressure is applied across the faces of a crystal, it will start to oscillate, vibrate, and from the vibration frequency will come, and from the frequency AC signal will be generated. Yes or no? Waves are generated.
Yes sir.
Now in the alternate way we can go. If we apply the AC voltage, the quartz crystal can vibrate. Okay. So if the quartz crystal can vibrate, it will produce also the frequency due to vibration. Okay.
Yes,
that is called a piezoelectric effect. So you can write one line here: crystal oscillator, characteristics of a quartz crystal. This diagram, why it is shown to you, this diagram, let me tell you. This small diagram is meant for your how the crystal is mounted. You can see a small black rectangular piece is there. That is the crystal. When you use the crystal in the circuit, it will replace the circuit by such type of tank circuit. What is the tank circuit? Tank circuit is nothing but the combination of series resistance, inductance, capacitance, RLC, parallel with one capacitance that is called mounting capacitance CM. From where this mounting capacitance comes? This mounting capacitance comes from the crystal, because the crystal is placed between two metallic plates. So when insulator is placed between two metallic plates, that is acting like a capacitor. In plus 2 that you have studied. Yes or no?
yes sir.
Now you see a quartz crystal exhibit the property that when mechanical stress is applied across the faces due to potential difference across the opposite faces, vibration will start. This is called piezoelectric effect. You can write this one line. A quartz crystal exhibit a very important property, that is what? That is when a mechanical stress is applied across one set of its faces, a difference of potential develops across the opposite faces. That is called a piezoelectric effect. And also we can apply this in a reverse way. What is the reverse way? When potential difference will be applied to the crystal, it will vibrate, and when it will vibrate, it will produce the frequency of oscillation. So this concept is used in this oscillator. That's why this oscillator name is called crystal oscillator. It is different from other oscillator. Why? In other oscillator, tank circuit was there. Suppose for example RC phase shift oscillator you have seen. So in the tank circuit means what? The circuit which determine the frequency of oscillation. So in RC phase shift circuit, what was the tank circuit? It consisted of resistance and capacitance. Okay. Now here crystal is there. That's why crystal we have replaced by one equivalent circuit, that is this equivalent circuit, which consists of series RLC element parallel with mounting capacitance. Sometime a 2-mark question is asked in the BPUT exam. Draw the electrical equivalent circuit of a crystal. So this is the electrical equivalent circuit of a crystal. This diagram you have to draw. You will get 2 marks. Okay.
Yes, sir.
So we can connect this quartz crystal in 2 different ways. You can see the 2 diagrams here. The 2 oscillator circuits are made. First one is made by BJT, second one is made by JFET. Sorry, depletion type MOSFET. So in which path it is connected? Series mode or not? Extal means crystal. Okay, extal means crystal. No need to draw the second diagram. You can draw this first diagram. Extal means what? Crystal. So this circuit is constructed by using what? Using a BJT, bipolar junction transistor. In which bias mode? Voltage divider bias mode. Okay. First to draw, then I will explain you the operation of the circuit. Only left side diagram is required. Right side is not required. Okay.
Okay, sir.
When you complete, tell me. Whatever, but excess will be try to understand the circuit. The circuit we have discussed in amplifier, that is voltage divider bias amplifier. But there is some difference here. What is the difference here? You can see in place of collector resistance, what is connected?
Inductance.
Inductance. That inductance name is called what? RFC. Write down the full form of RFC. That is radio frequency choke. That is the radio frequency choke. What is the responsibility of this RFC? It will allow DC but block AC. Write down. RFC will allow DC but block AC. Now see, VCC is what? AC or DC? Abhishek.
Yes, sir.
VCC is what? AC or DC?
सर AC.
VCC का VCC जो है VCC DC है.
Yes, sir. DC.
DC है सर, DC है VCC.
ऑसिलेटर क्या करता है? DC को कन्वर्ट करता है AC में. इन DC को लेता है और आउटपुट में AC प्रोड्यूस करता है ना. तो ये जो VCC DC है, ये RFC के थ्रू पास हो सकता है. It is acting like a filter. It will allow the DC to operate the device. If VCC will not come to the BJT, BJT will not be operated. Q point cannot be determined. Okay. ठीक है. But it will block the AC. AC कहाँ से आ रहा है? AC output से आ रहा है. When we take the AC, it will block the RFC will block the AC, and this coupling capacitor will allow the AC, so that the AC signal is applied to the crystal. Okay. And as per the piezoelectric effect, when AC signal is applied to the crystal, what will happen to the crystal? Crystal will vibrate or not?
Yes, sir. Generate frequency.
It will generate the frequency. So oscillator operation can take place and frequency can be generated. So in this connection, crystal is connected in the series path, in the feedback path, series path. That's why the mode is called series resonant mode of operation. Series resonant mode of operation. Similarly, another diagram is there that is called parallel resonant mode of operation or parallel resonant circuit. You can draw this circuit for parallel resonant circuit. You can see in the parallel path the crystal is connected or not. Randhir, in the parallel path across the output terminal, the crystal is connected. Okay. Avilipsa.
Sir.
Here in the parallel resonant circuit, the crystal is connected in the parallel path.
Yes, sir.
Puja Panda, are you there or not?
Yes, sir.
Are you getting understanding?
Yes, sir.
Yes. If anyone having any problem, you can ask, but try to understand the effect of RFC. RFC always it will allow the DC pass the DC, but block AC. Have you completed the diagram?
No, sir.
Do it. So in exam, it is a very important long question for you. It will be asked to you, explain the operation of crystal oscillator. So the mode may be asked, series mode or parallel mode. Accordingly, you have to explain it. Sometime a 10-mark question will be asked. So both the mode you have to explain, series mode, parallel mode. So you draw in the meantime also you understand. So once again, this is a voltage divider bias network, and you can see the output side. Across the output terminals, C1 and C2 are connected. So C1 and C2 are what? C1 and C2 are capacitive divider network. So C1 and C2 are capacitive divider network. So what will happen in the capacitive divider network? From output terminal, some voltage will be stored across capacitor C1, some voltage will be stored across capacitor C2. So whatever the voltage is developed or stored across capacitor C2, that will take it as feedback voltage. Okay, that is taken as feedback voltage and it will be given to the input of the BJT through the capacitor CB, coupling capacitor CB. So in the feedback path, the signal is getting added to the input side. Once again, RFC function is same. It will allow DC, block AC. So whatever the AC we are taking from the output terminal, that will not go to RFC. That will be coming towards C1 and C2. And due to this cyclic operation, frequency will be generated by the vibration of the crystal, which is connected in the parallel path. Since the crystal is connected in the parallel path, it is known as parallel resonant mode. This is the end of the oscillator chapter. New chapter of pump we can start in offline class Monday onwards. Okay, so 4 modules are completed. Only one module is left. Okay,
Sir, from Monday offline classes.
offline classes from Monday. Old timetable, whatever the timetable was there, you can see timetable was there.
Today last online class, na sir?
Yes. Who knows? Once again, government may once again tell. So let us go as per the guideline. But for this semester, it will not be because next month you are having the exam.
Yes,
March
sir.
सेकेंड वीक।
सर कोरोना भी ऐसे इफेक्टेड है नहीं उतना?
इतना ज्यादा नहीं है, सीरियसनेस नहीं है, हल्के में जा रहा है। सर्दी जुकाम हो रहा है और 2-4 दिन के बाद सब ठीक हो जा रहे हैं।
यस सर। सर ऑफलाइन होना जरूरी है सर, ऑनलाइन में कुछ पढ़ाई नहीं हो रहा है।
तुम लोग भी सोच रहे होंगे कि ऑनलाइन एग्जाम होगा, पढ़ने का जरूरत नहीं है।
यस सर। सर यही सब पढ़ने नहीं देता है सर, माइंड में बैठल रहता है कि ऑनलाइन एग्जाम होगा।
हाँ। अभी 1 महीना पहले अगर पता चलेगा कि नहीं ऑफलाइन एग्जाम देना है तो कुछ पढ़ोगे।
यस सर।
यस सर।
AC students, you can attend your roll calls fast. अभिषेक बेहरा, अभिषेक साहू,
यस सर।
अभिषेक राज,